Welcome back to Course 101, Symbol Fundamentals. In this course, we'll take a look into symbol architecture. Symbol implements a 4-tiered architecture design for added security, scalability, and ease of development. The first 2 tiers are internal tiers that are at the protocol level. The first tier is the core of the blockchain that is made up of peer nodes. The peer nodes communicate with API nodes. REST gateway is the next tier, which communicates between the API and the clients. REST gateway and the client tiers are external tiers that users have more direct interactions with. So to understand the 4-tiered architecture, let's follow a transaction as it navigates its way through all 4 tiers. Let's start with the tier consisting of apps and resource-efficient clients. Let's imagine that Alice wants to send 100 digital claps to Bob over the Symbol platform. She grabs her phone and opens up a Symbol wallet app to enter the following data: Bob as the recipient of her digital asset, the claps created as a digital asset on Symbol, 100 as the total amount of claps she wants to send, and the maximum amount of fee she is willing to pay in order for this transaction to get through. The transaction fee must always be paid with XYM, no matter what mosaic she is sending, because XYM is the currency native to the Symbol blockchain, which is also a mosaic. A transaction fee is used to incentivize and pay validators to process the transaction. Alice presses send when she confirms all the data is correctly entered. Before the transaction is sent to the Symbol network, the software development kits gather all the information together and have the transaction signed by Alice's private key. The wallet app then announces the transaction to the network. Now, up until here, Alice is accessing the clients and SDKs tier of the Symbol architecture. Through its higher level of abstraction, the SDKs free up developers to focus on product development rather than on the Symbol-specific API details. The SDK connects directly with the REST node, which makes up the next tier. REST nodes take the requests from the clients, read and write on the blockchain, and notify the clients via WebSockets. This tier exposes all the features available through a RESTful API contract. Each REST node connects to one API instance and a MongoDB database. This leads us to the next tier. The primary responsibility of the API nodes is to store the data in a readable form in MongoDB. Blockchains are a secure method of data storage, but they're not the most efficient in terms of data retrieval, because it is stored in a binary format. Replicating and storing data in MongoDB allows the client apps to access the data very quickly through the REST nodes. Importantly, this allows for more efficient and easier scaling of the entire network. Other than transactions, MongoDB also stores blocks and chain states. The API nodes push new transactions to the peer-to-peer network for validation. After being validated and included in the block, API nodes write data to MongoDB. It does not do it directly, but it writes into a file-based queue called spool. A broker service will then update MongoDB accordingly and notify REST gateway via 0MQ. Now, the last tier consists of peer nodes, the backbone of a blockchain. Here, the transactions pushed by API nodes are propagated to the network for validation. Invalid transactions will be discarded, and valid transactions will be grouped in blocks and linked cryptographically. The changes are then stored as a flat file on disk and the updated chain state in RocksDB. This tier also contains the consensus algorithm that moderates the blockchain servers. Symbol uses an original blockchain protocol called Proof of Stake Plus. We will go more in depth about this in the next lesson. This tier also gives Symbol the standard benefits of blockchain technology, like transparency, security, and traceability. Referring back to the example introduced earlier, after Alice presses the Send button, the transaction data is compiled and announced to the REST gateway. A notification will be returned immediately. But at this point, it would remain unknown whether the transaction is valid. The first stage of validation happens in the API nodes. If the transaction proves to have an error, it's communicated to the REST nodes, where the WebSocket will send a notification through the status channel and be displayed by the wallet app. If Alice uses a multi-sig account to send the transaction, the API nodes are also responsible for collecting all of the required signatures. If there is no error and all signatures are in place, then the transaction is pushed to the peer-to-peer network. It would be in an unconfirmed status as it has yet to be included in a block and cannot be trusted. The peer nodes validate if Alice has enough of the clap mosaic in her account. If there is, then the transaction is processed. The 100 clap mosaics will be debited from Alice's account and credited to Bob's account. In addition to the 100 clap mosaics, a transaction fee will also be deducted from Alice's account and rewarded to the validator for processing the transaction. The data will then be updated in RocksDB and MongoDB. The wallet app will be notified via REST gateway. The transaction is now considered confirmed. As you can see, the four-tiered architecture gives developers an easy way to build on Symbol and utilize blockchain technology. Developers will only need to work on the clients and SDKs tier. In upcoming lessons, we'll learn how to take advantage of development tools that are provided by Symbol. Symbol, powering possibility.